All right, let's jump right into this explainer. Today we're looking at how the latest SASB standards are essentially forcing coal operations to put hard, exact numbers on their most invisible impacts: greenhouse gases and water stress. If you've ever wondered how global financial markets actually attempt to measure the environmental realities of mining, you are in the exact right place.
Here's our roadmap for today. We'll hit standardizing coal's impact, tracking GHGs, the Scope 1 mandate, measuring water demands, tracking high water stress, and finally wrap up with why these metrics matter. Let's get into it.
Starting off with Section 1, Standardizing Coal's Impact.
Under the International Sustainability Standards Board, these SASB standards don't just ask nicely, they mandate that entities disclose very specific sustainability-related risks. Why? Because these are risks that can totally affect cash flows, access to finance, or the cost of capital over time. We aren't just talking about PR or environmental goodwill here. This is about hard financial realities and giving investors data they can actually compare.
Moving on to Section 2, Tracking the Invisible, GHGs.
So how exactly do we measure the invisible gases from coal mining? Well, coal operations are just incredibly energy heavy. They generate massive direct greenhouse gas emissions. We're talking carbon dioxide from the fuel used to run those giant machines, sure, but also the completely invisible methane released directly from coal beds during and after mining. And when you remember that methane packs over 25 times the warming power of CO2 over a century, tracking this massive unseen footprint is absolutely crucial.
This brings us right to the gold standard of tracking, Scope 1 emissions. Companies have to calculate these direct emissions using the exact methodology of the widely recognized GHG protocol. It's comprehensive, covering everything from stationary and mobile equipment at the mine to coal seam methane, all the way to storage facilities and transport. And notice the word gross here. That means they have to report these emissions before factoring in any offsets or carbon credits. There's no hiding behind credits.
All right, Section 3, the Scope 1 mandate.
To make sure we have complete uniformity across the industry, companies can't just hand over a hodgepodge of different gases. All 7 greenhouse gases covered under the Kyoto Protocol, methane, nitrous oxide, the whole shebang, have to be consolidated. They are strictly reported in one single unit, metric tons of carbon dioxide equivalent, or CO2e. They figure this out using published 100-year global warming potential values. It's all about getting everyone speaking the exact same language.
And here's where it gets really interesting. Once a company figures out its total gross global Scope 1 emissions, it has to calculate the exact percentage of those emissions subject to emissions-limiting regulations. We're talking cap-and-trade schemes, carbon taxes, things like that. For an investor looking at a balance sheet, this percentage is a massive indicator. It shows exactly how much of a company's bottom line is directly exposed to strict climate laws.
Next up, Section 4, Measuring Water Demands.
Pivoting from air to earth, what is the exact difference between the water a coal mine takes and the water it actually uses up? Coal operations are incredibly thirsty. They use vast amounts of water to wash coal, to remove sulfur, to cool down drilling equipment, and to push coal through slurry pipelines. Because it's so water-intensive, the SASB standards draw a really vital line between 2 distinct water metrics.
The precision here is key. Total water withdrawn literally means every drop of water brought onto the site, whether they pump it from wetlands, rivers, groundwater, or municipal supplies. Total water consumed, on the flip side, strictly means water that is essentially lost to the local environment. Stuff that evaporates, gets permanently incorporated into the product, or just isn't returned to the same catchment area. It's a critical distinction.
And just like with the emissions data, these water metrics can't be vague. The standard requires that both withdrawn and consumed water be quantified exactly in thousands of cubic meters. To put that into perspective, just 1,000 cubic meters is about 40% of an Olympic-sized swimming pool. Having this hard metric allows for a true apples-to-apples comparison, whether you're looking at a mine in Australia or one in North America.
Which brings us to Section 5, Tracking High Water Stress.
Because volume really isn't the whole story, right? Geography dictates the actual severity of the impact. Pumping 1,000 cubic meters of water out of a rainforest is very different than taking it from a desert. Because of this, companies have to run all their operations through an objective tool, the World Resources Institute's Aqueduct Water Risk Atlas. They literally map out their sites to flag any activities in regions classified as having high baseline water stress, which means 40 to 80% stress, or extremely high stress, meaning anything over 80%.
Once they've mapped everything out, the mandate gets even tougher.
They have to disclose the exact percentage of both their withdrawn and consumed water that comes directly from these high-risk Atlas regions. Think about that. It takes the invisible drain on vulnerable local resources and puts it right there on the balance sheet. It highlights for everyone exactly how much of a company's operation depends on water that is already dangerously scarce.
Finally, Section 6, why these metrics matter.
So by standardizing these seemingly dry technical codes and requiring highly precise units of measure, the SASB framework does something kind of brilliant. It turns totally abstract environmental concepts into hard comparable data. Investors and regulators don't have to just trust vague sustainability promises anymore. They can look right at the metric tons of CO2 equivalent or the thousands of cubic meters of stressed water and directly evaluate the real operational risks.
Ultimately, the old business adage really does hold true. What gets measured gets managed. Will forcing companies to systematically put a hard, audited number on every single drop of stressed water and every ton of invisible gas be the ultimate catalyst for transforming energy accountability? That is the billion-dollar question these standards present to the entire industry. Thanks for joining me on this explainer, and I hope this dive into the SASB metrics gives you a totally new lens for viewing corporate sustainability.